Hi all, greetings from Vedvyasa Institute of Technology. Myself Jijin KM, Assistant Professor, Department of EEE. Today I am going to discuss about the topic Introduction to Electrostatics. In a glance, today I am going to discuss about Introduction to Electrostatics, that is what is electrostatics and what is charge, types of charge, cause of charge, and laws of electrostatics, that is first law and second law, also known as Coulomb's law of electrostatics. So what is electrostatics? The electrostatics can be split into two, that is electro and statics. Electro means charge and static is rest. So by definition, electrostatics is the study of the behavior of stationary charges. What is charge? In order to understand what is charge, we can do an experiment. That is, if we are using a comb and if we are rubbing that comb with our hair, and if you are placing that rubbed comb nearby some pieces of paper, we can see that papers are attracted towards the comb. So why it's so? It is only because of the creation of charges on the tip of that comb. So by definition, we can say that charge is the property of that material due to which it exerts a force. Next, we are looking into types of charge. In order to understand what kind of charges are there, we are conducting or we are considering three cases. That is in case A, that is case A. In case A, two glass rod of same materials are rubbed by using a silk thread and are keeping very near. And in case B, two same kind of materials, that is plastic rods, are rubbed by using silk thread and keeping very near. And in case C, different kind of material, that is silk thread and plastic rod, are rubbed by using a glass rod and plastic rod are rubbed by using a silk thread and keeping very near. In case A, we can see that two glass rods, if we are keeping the glass rod very near, we can see that two glass rods are repel each other. In case B also, if two plastic rods are near, we can see that they repel each other. But in case C, we can see that the glass rod, we are using glass rod and plastic rod. So if we are keeping it each other, we can see that they will attract each other. Why it's so? So from the experiment, we can see that same kind of materials is repel each other, but different kind of materials are attract each other. That means in the same kind of material, same charges are produced. That's why they are repel each other. But in different kind of material, opposite charges are created. So they will attract each other. So we can basically say that there are two types of charges, that is positive charge and negative charge, and it is introduced by Benjamin Franklin, the scientist Benjamin Franklin. And the SI unit of electric charge is coulomb, and 1 coulomb is equal to 6.24 into 10 raised to 18 electrons. Now we are looking into laws of electrostatics. Next, basically there are two laws of electrostatics, that is first law of electrostatics and second law of electrostatics. Second law of electrostatics also known as Coulomb's law of electrostatics. So by considering first law of electrostatics, it tells that like charges repel each other and opposite charges attract each other. Here we can see that these positive charge, these two both positive charge, both are to positive charge, so they are like charges or same kind of charges, they will repel each other. You can see that the force acting on between them is outward. Also similarly, these are two negative charges, that means they will repel each other, that is like charges repel each other. Then opposite charges attract each other. Here we can see that this is positive charge and this is negative charge. These are opposite charges. These opposite charges attract each other. This is first law of electrostatics. Next is second law of electrostatics, which is also known as Coulomb's law. So for understanding Coulomb's law, we are considering two charges, that is Q1, which is a positive charge, then in Q2, this is a negative charge, and are separated by distance of small r. So there will be a force of attraction between them, that is F. And Coulomb's law tells that this force exerted between 2-point charge, or this force of attraction is directly proportional to the product of their strength, that is Q1 and Q2, and inversely proportional to the square of the distance between them, that is r square, then inversely proportional to the absolute permittivity of the surrounding medium. Actually, permittivity is the medium dependent term. So we can convert this law into equation, that is for considering a medium. For a medium, we can write the force equation Fm as k into q1 q2 by r square, where k is equal to 1 by 4 pi epsilon or epsilon 0, that is also known as electrostatic constant, and which will be is equal to, the value will be is equal to 8.99 into 10 raised to 9, or it can be approximated as 9 into 10 raised to 9 units, where q1 is equal to charge of first object and q2 is equal to charge of second object, and r will be the distance between two charges, and epsilon r is the relative permittivity of the medium. For vacuum or air, epsilon r will be is equal to 1, and epsilon 0 will be permittivity of free space, which is equal to 8.85 into 10 raised to minus 12. And if we are considering vacuum, we can write epsilon r as 1, so the equation became 1 by 4 pi epsilon 0 into q1 q2 by r square. Then if you are taking the ratio Fe by Fm, that is Fe means force for vacuum and Fm means force for a medium, then the ratio will be is equal to epsilon r, that is relative permittivity of the medium. Next I am going to discuss about the one example of electrostatics, that is lightning and thunder. We know that clouds will be there in sky, and these clouds consist of ice crystals and water droplets. If the clouds are moving, the crystals, ice crystals and water droplets in these clouds will rub each other if they are moving. So the charges will be produced in the clouds, and this positive charge will be aligned in the top of the cloud, and negative charge, that is electron, will align in the bottom of the cloud. At the bottom of the clouds, it will be more negative, that is more electrons are at the bottom of the cloud. Usually whenever the clouds are more negatively charged at the bottom, and the earth, basically earth will be a neutral object, but whenever the cloud is more negatively charged at the bottom, electrons are pushed downwards and the surface of the earth will be more positive, and also all the objects on the surface will be positively charged. So electrons in the cloud is more, that is cloud is more negatively charged and earth is more positively charged. So the electrons in the cloud will try to enter into earth by using an easy path. So electrons in this cloud will find out a way to reach earth by through air. So discharge of these electrons will occur, and we can see it as lightning. During lightning, the air surrounded by the lightning will heat up to 30,000 degrees Celsius. So the air will expand and it will produce as a shock wave. Actually, shock wave is a high pressure wave, and this shock wave is converted into sound wave, and we are hearing it as a thunder. Actually, lightning and thunder are almost occur at the same time, but we are seeing lightning at first, and after few minutes only we are hearing thunder. Why so? It's only because the velocity of light is more than that of velocity of sound. Thank you all.